Good day everyone. Welcome to all. My name is Sachin Ahankari, working as Assistant Professor in Narasimha Reddy Engineering College in EC department. So today in this session we will see about the features of op-amp and the inverting amplifier using op-amp. So the features of op-amp, the first feature is dual supply voltage. You are applying as plus VCC and minus VEE. It is generally ranging from plus or minus 1.5 volt to plus or minus 15 volt. In general, you are applying the voltage of 12 volt to 15 volt to the plus VCC and minus VEE pin of the op-amp IC. No frequency compensation is required. So generally you are using the resistors and capacitors, the network of resistors and capacitors in order to control the gain of the amplifier. So this network is generally outside of the op-amp for the first generation, but afterwards for later generations these resistors and capacitor networks which are required to control the gain, they are fabricated inside the IC. So there is no external resistors and capacitors are required to control the gain. So that's why no frequency compensation is required here, generally outside here. And short circuit protection is given for the 741 IC, and offset voltage null capability is also there. And next is large common mode and differential voltage ranges you can achieve with the help of this op-amp. No latch-ups. Latch-up is again a type of short circuit. Uh, Generally, a low impedance path is provided between the supply pin and ground. So, in the latch-up, so there is a no latch-up and short circuit protection is given to the op-amp. Low power consumption. The amount of power dissipated or consumed by the op-amp, uh, it is 85 milliwatt. It is in 85 milliwatt, and unity gain is stable, and balanced offset null is provided in the op-amp, and also supply current is less than 300 microampere per amplifier at 5 volt is achieved here. So these are the few features of op-amp. Now we will see the inverting amplifier using op-amp. We are also going to derive the closed loop voltage gain for the inverting amplifier. So open loop voltage gain is a ratio of output voltage to the differential input voltage. So open loop voltage gain is equal to V0 divided by VID. So open loop voltage gain is V0 divided by VID, and the closed loop voltage gain is the ratio of output voltage to the input voltage. So output voltage is V0 and the input voltage is Vin. So for closed loop voltage gain, it is V0 divided by Vin, and for open loop V0 divided by VID. So we are interested for the calculation of closed loop voltage gain, that is V0 divided by Vin. So here in the inverting amplifier, the input voltage is applied to the inverting input terminal, and non-inverting input terminal is grounded here, and the supply voltages are given to pin number 7 and pin number 4. To pin number 7 plus VCC is applied, to pin number 4 minus VEE is applied. I have not shown here in the op-amp, you have to show it here. For pin number 7 VCC, pin number 4 minus VEE, from 12 volt to 15 volt you can apply over here. So here the input voltage is applied to the inverting input terminal and non-inverting input terminal of op-amp is grounded, and here the feedback is provided to the inverting inverting input terminal. That's why it is a negative feedback. The part of output voltage is given to the inverting input terminal of op-amp. That's why it is a negative feedback. So here, by considering op-amp as ideal, uh, two conditions we are going to consider. The first is open loop voltage gain is infinite. Open loop voltage gain is infinite means V0 divided by VID is infinite. V0 divided by VID is infinite means VID is equal to 0. VID is equal to 0 means the differential input voltage, that is positive terminal voltage minus negative terminal voltage, is 0. That is V plus uh, is equal to V minus. V plus is equal to V minus. So VID is 0 means V plus minus V minus is equal to 0. That is V plus is equal to V minus. So here, whenever the negative feedback is given to the op-amp, then it will try to achieve VID is equal to 0. Since this terminal is at ground potential, so the feedback is provided in such a fashion that VID is equal to 0 is maintained. So if this non-inverting input terminal is at 1 volt, then the feedback is provided in such a fashion that here the potential will be 1 volt. So in that fashion, the output it is going to provide the negative feedback such that VID is equal to 0. Since the inverting input terminal is at ground potential, therefore the potential at inverting input terminal is also 0. So here the potential at non-inverting input terminal is 0 and the potential at inverting input terminal is also 0, and it is achieved with the help of this feedback. So no current is going to flow into the input terminal of op-amp. So it is one of the rule of op-amp that no current is going to flow inside the input terminal of op-amp, as well as no current will go outside. No current will go inside, as well as no current will go outside. So whatever the current is supplied here, that current is flowing through the R1 and the voltage drop is I1 R1, and the same amount of current will flow here. Since the current will not flow into the input terminal, therefore the same amount of current will flow through the RF. So I1 is equal to IF. I1 is equal to IF. So I1 can be written as V in minus V minus divided by R1. So which is equal to V minus uh, minus V0 divided by RF. So here, by virtual ground concept, V minus is 0 here. That's why putting V minus is equal to 0 here. You can write it as V in divided by R1, which is equal to minus V0 divided by RF, and the output voltage is equal to minus RF by R1 into V in, or the closed loop voltage gain, that is V0 divided by V in, is minus RF by R1. So here if you apply the positive cycle to the inverting input inverting amplifier, we will get the negative cycle at the output here. So here, if I consider this as 1K, if I consider this as 10K, 1K and 10K, if I am applying 1 volt here, 1 volt and 1 milliampere current is going through here. So 1 milliampere into 1K, that is 1 volt will be the voltage here, and the same amount of current is flowing, that is 1 milliampere, 10K, that is 10 volt will be available here. So 1 volt here plus plus or minus 10 volt, and here the negative 10 volt will be available here. So the minus of 10 volt will be available. So if it is 1K, if it is 10K, the volt, if it is 1 milliampere, 1 volt, and 1 milliampere into 1K is 1 volt, and 1 milliampere into 10K is 10 volt. So here in order to maintain VID is equal to 0, here it should be minus 10 volt. So this 10 volt and this 10 volt is going to cancel each other, and here you are going to get the VID is equal to 0. So feedback is provided in such a fashion that VID is equal to 0 is achieved. So this is for positive cycle output voltage for positive cycle, amplification factor is RF by R1. So here, as it is 1K, it is 10 times, so it will be 10 times amplification. If I go for another factor also, you can achieve the amplification, but you cannot achieve the amplification more than the battery supply voltage. So it is a rule of physics that you cannot achieve the uh, amplification more than the DC supply voltages. So if the 15 volts are applied, maximum amplification will be 0.9 times your VCC. That is, if I am applying 15 volt, then 13 volt approx will be the maximum amplification provided by the amplifier. So this is about your inverting amplifier. We will study non-inverting amplifier, and we will calculate the closed loop voltage gain for non-inverting as well as a differential amplifier using one op amp in the next lecture. Thank you.